Hello everyone, my name is Priyanka and I welcome you all to my session. Let's read our question. It says that a device X is connected to an AC source of voltage V which is equal to V naught sine omega t. The variation of the voltage, current and power in one cycle is shown in the following graph. So the graph is given to us and there are four subparts for this question. The first is identify the device X, then which of the curves A, B and C represents voltage, current and the power consumed in the circuit, and the third part, how does its impedance vary with the frequency of the AC source, show graphically, and then the last part, that is obtain an expression for the current in the circuit and its phase relationship with the AC voltage. So when we observe the graph carefully, we're going to note that this device X is a capacitor. All right. Now, the curve A shows here the power consumption over the full cycle. So, A is for power. The curve B shows the voltage. So, we can see that B is for voltage. And the curve C shows the current. As in a perfect capacitor, the current leads the voltage by a phase angle of 90 degrees. So if we say that C is going to be current, because we can see here that it is leading the voltage by a phase angle of 90 degrees. So that was the first part, that is it was a capacitor. The second part, now let's talk about the third part, which says that how does its impedance vary with the frequency of the AC source. Alright, so very well we are knowing that XC is equal to 1 upon omega C, and it is also equal to 2 pi mu C. That means we know that this XC is inversely proportional to the frequency. So if we draw the graph between XC and frequency, it is going to have an inverse relationship and it is going to be something like this. Inverse graph is always the standard graph. So let's take this as the y-axis and let's take this as the frequency, which is the x-axis.